Hello everybody and welcome to this video. In this video, we'll be estimating the differences between two means. These are not plausible values. These are hourly earnings in PIAAC. So in this video, we're only focusing on section D of the script. You'll find other videos on each section here. The overall rationale for the script is available here. Here it is. My colleague and I, Kaidar, write this rationale and also provide some key references. For example, the technical report, which can be found here. If you're interested in all the formula, you can find that here. All right, so my name is Matthew, and let's get started. So let's start with sourcing our data. Our public use files can be found for each country from this address here. The OECD codebook can be found here, and the technical manual here. Now, when we're running our script, we need to connect our script to a certain folder. This is called our working directory. Now, to do this, you need to put important files in that folder first. So obviously we need the original data. Here we're using Austria. The code book is also important to have for a reference so that you check how each variable is coded. And also you need obviously this script as well in this folder, this R script. So once you've done that and you've got your folder set up on your desktop or on your Mac, you can make a connection between the R script and that folder. You can do that by running code. Here, I just highlight the code and press Command Enter on my Mac or Control Enter on a PC. You can also do it at the end of the line of code as well. If you want, you can set it up manually, the connection, by going to Session, Set Working Directory, Choose Directory, and doing it manually that way. Obviously, this is a new task that I'm doing, so I need to clear the global environment from what I did before. So you can do that by running this script. You can also use the broom up here. You can also clean down here as well in the terminal, in the console. Okay, next step is package management. Obviously in R, we're using some different packages, freely downloadable from the internet. In order to manage the packages for each project, I use a package called Pacman. By running this code, we install and load Pacman to the library if we need it. This might take a while to install. You just have to wait and watch the progress down here. Next, we use this Pacman package to install and load these three packages that we're using here. Again, this might take some time to install and load from the internet. Next, we read in the data. For this video, we're just going to read in the Austrian SPSS file, which is a .sav file. And we can just read that in using the foreign package. The foreign package helps with other types of files as well. I think Stata files as well. It's quite useful. So we're reading this data into R and we're assigning it the name data up here as a data frame. Here's the progress down here. It might take a while, and then it's done. I use the dim function, the dim base function, to check the dimensions of the data frame. we can see it has 4,565 rows and nearly 2,500 columns. It's quite a big data set. We can check the method as well. This is important. Okay, for later. Let's also look at the plausible values and the variables of interest. I run this code here inside R so that I can see all outputs. This options code here. Let's just look at the first plausible value. Okay. But we're not really interested in the plausible values, right? So we're interested in earning power and how earning power might be different by gender. So we can just run this code and check all the different earning power variables, what might be interesting to us, what might have the most comprehensive data points, and so forth. You can use psych, package, and describe function is quite useful. Here we assign the earning power, which is a decile variable, as a numeric. And we can run our basic averages and so forth on that numeric variable here. It's a type of quasi-continuous variable. Of course, we need to also account for weights. So we have our final full sample weight. It's a numeric. And we also have our replicate weights. There are 80 of them for Austria, but other countries have fewer. For example, Portugal has 52, US has 44, Chile has 28. And you can check all that here. So let's skip to section D. Okay. So we're estimating differences between two means, hourly earnings, and these are obviously non-PVs. So we're not using plausible values in this case. We're just accounting for weights. So let's focus on the non-PV name. That is the name of the variable we're interested in. Here we can find the position of that variable inside the data, which is really big, right? So we want to know what column it is. There's the position there, the 2,326th column. Let's find the sample and replicate weights positions, and here they are there, the 81 positions. And we can find the number of replications. It's 80 in this instance. Here are the exceptions. Now, this is a big data set, so it's better to run functions on smaller data sets. In this case, we're going to just reduce to the variables of interest, which is our non-plausible value, and also our weights. So let's change let's reduce and refine the data frame. This data frame has the same number of observations, but also only 82 variables now. Let's join the data frame with gender, and here we have earnings, final sample weight, replicate weights, and gender. Let's rename gender to make it more clear. Okay. Excellent. Looks good. Now, in terms of missing data and how we deal with missing data, in this video, I'm just using a type of, I think it's called listwise deletion. We're just removing cases if they don't have complete numbers. So when I do that, or when I do any such adjustments, I like to put the dimensions function before and after I run that code, just to see the result. So yeah, we see that we have data for 4,565 Austrians, but only 2,785 gave information on salary. And we can describe this earning by gender, but we're not accounting for weights, right? looks like males are earning more, but we don't really, we don't really know exactly what the numbers are because we're not accounting for weights. So from this point, we can set our constant. If you're France, then run this code, not that code. So you need to unhash. But if you're not France, then leave it hashed. Let's generate these functions and watch the functions populate over here in the global environment. Now we can run our functions. Let's see differences in non-PVs. Let's run the function. There we have the difference and the standard error. So let's check for our two results. We have an estimate and final variance. It's like a standard error. Here we go again. We can print them. There's the estimate and there's the final variance or error term. Difference and standard error, let's just rename them. And we can use this type of t-statistic of the absolute difference divided by the standard error, like the signal over the noise. That's our t-stat. It's quite large. If you've done any t-tests, you can see that that's quite large. Here we can convert the t-stat to the p-value, and we can see the result here in full, because we ran that code. Remember, the options code. Okay, so there we have it. There are our results for the differences in two means, which are not plausible values. I hope this is helpful. If you have any questions, then you can ask them in the comment section below. Thank you so much. Bye-bye.